Hello there, this is Will, and I'm going to be doing just a problem on page 329, and this will be section B, I believe. And so this is going to be problem number, looking at all the interesting problems here. I think I'm going to do number 3. Yeah, I'm going to start with number 3. And we're going to determine whether or not this is self-contradictory, contingent, or a tautology. And because we know how to construct a truth table, it's going to be pretty easy for us to do. So number 3 reads as an argument or as a statement. Okay, it's important to make sure that this is a statement. It reads as P and Q and P then not Q. Well, how many letters do we have that are distinct here? Well, just P and Q, because all the negation does, remember, all negation does, is it inverts truth value. So that's not actually a real new variable, new letter. So we don't have to treat it as such when we do our truth table. So let's go ahead and start truth table. We'll need a P. We'll need a Q. Let's see here. I don't like the way this truth table is starting. It's not pretty enough. All right, I'm going to start over. Okay, so we got a P and we got a Q. And let's see here. One truth, one false. One truth, one false. Two truths, two falses. And looks like that's gonna be it for our truth table, really. I'm just drawing some lines to try to be just a little bit clearer, because this stuff can get confusing, when you have a bunch of lines and they're uneven or unclear or whatever. So I'm just trying to neaten it up as much as possible to avoid confusion. And I apologize if that is slightly annoying. Okay, so we got our little truth configurations, and now we got to our columns of trues and falses. So that's all possible combinations there of P's and Q's. So we need to see how many molecules this statement is made out of, and we have one here, we have one here, and we have one here. So it looks like we have 3, right? So let's take the smallest first, which I believe will be this one over here. We'll just go ahead and expand our truth table a little bit. So we'll make this P and Q right here. We know, let's just expand the lines, keep it neat the best we can, might as well. We have nothing else to do, right? So let's just keep expanding that. All right. So we know that when P is true and Q is true, this is true. When 1 is false, it is false, so that's false. We have another false one, and that's false, right? So, here we have the second piece, right? Well, this is another smaller conjunct of the larger conjunction. So let's do this one first, right? So P, but we notice there's a not Q here. There's a not Q. So let's go ahead and write out not Q. This should not be that difficult. We just make that false, that true, that false, and that true. And that inverts the truth value. So now let's do if P, then not Q. And remember our rules for the horseshoe. That is that the horseshoe is only false when the antecedent is true and the consequent false. So that that's what defines the horseshoe. And let's see how that works out for us. I'm going to just change colors. So P is true and not Q is false. So that's false. All right, so not Q is false, P is true. Makes it false, right? Okay, so P is true again, not Q is true, so that's true. P is false, not Q is false, so that's true. And then we have a false and true, which is a true. So it's only false right here. All right. So now we have our big connector, which is going to tell us whether or not this is contingent, self-contradictory, or tautologous. So let's go ahead and put it all together. We have P and Q, and we have and if P, then not Q. And we already have the values worked out, so this is just a matter of really mindless, following rules. Whoop. All right, let's just go ahead and change the color around a little bit here. Let's go ahead and make that yellow. Okay, so remember we're doing this one right here. Okay, so when P and Q is true, so P and Q, and if P then not Q is false, that gives us a false, right? Now we can't just say this is going to be contingent because we don't know if it's going to be true at all, right? It could be self-contradictory, but we know for sure it's not a tautology, right? Okay, so here we are. P and Q is false here, and if P then Q is true here, so that and that is a false. Okay, it's true here and false here. Okay, so that is a false, and let's see here. This is a true and this is a false, so we know this is false, right? So this is self-contradictory, right? That was pretty straightforward how we did that. So why don't we try another one just really, really quickly. We're going to do number 6 on the same page. So let's see here. Okay, so we're going to do number 6. Sorry, I had to take a little break there. All right, so number 6, it states if P, then P, then Q and not Q. Okay, so there are only two distinct letters here, P and Q. The negation is just the inverted truth value, and it's not a unique letter. So so just be mindful of that. So we have let's just do a little truth table over here. We've got P, and we're gonna have Q, and let's just try to make this neat. Okay, so 1, 2. Oh man. 2 up. 2, 3. Oh man, what is going on with autocorrect today? 3 and 4. Okay, there we go. So just gonna try to neaten these up a little bit, so it's not totally hard on you. All right, let's just go for every one truth there, we've got one falsity. So let's go ahead and make that. Okay, for every 2 truths over here, we have 2 falsities. Okay, so we've got the truth table set up, and now let's look at our atoms. So it looks like, at least kind of like on the face of it, we got 1 here, right? We've got 1 over here, and then it looks like we got 1 big one, right? So how are we going to do this? Well, let's go ahead and start off with if P, then P. Seems like a good one to start with, right? So let's just draw some lines here. Get our table started. Just so we can make it a little neater. So the rule is when the antecedent is true and the consequent is false is the only time this is false. So if P then P, since it's got the same letter, namely P, well, this is going to be a true and a true, so that's true. This is going to be a true and a true, so that's true. It's going to be a false and a false, so that's going to be true. This is going to be a false and a false, so that's true. So it's true all the time. All right. So now let's just go over here to Q and not Q. And, this is a little bit weird to do because not Q and Q is actually a contradiction. So I'm just going to do not Q's values really quickly first. So I just draw a line here. And again, the negation just inverts the truth values. So we look over here at Q, and this is a false, and this is a true, and this is a false, and this is a true. I'm going to go ahead and switch colors a little bit. All right. So so now we can look at Q and not Q together, as weird as that may be. So let's just draw our lines here. Nice purple, bright lines here. All right, so let's see here. Okay, so Q is true, not Q is false. That gives us a falsity. Q is false. You get this, right? It's always going to be false, right? So I'm just going to write it as so because it can never be, in logic we kind of say this is absurd or a contradiction, but I'm just going to write it as a false on the truth table. So now we know this is kind of always false and this is always true, and so when we look at this thing, we know it's going to be self-contradictory, but let's just do the table. Let's just show the world we know how to do it, but we know the rule and we know how this stuff is working out. So let me just, all right, there we go. All right, so this is going to be if P then P. Let me change color. All right, if P, then Q and not Q, right? So a true and a false is what we have in the first one. True and a false is what we have in the second one. A true and a false is what we have in the third one, and for the fourth one. So this is also self-contradictory. And I hope that was helpful, and I'll see you in the next video.